This video is going to serve as a bit of an intro to what are known as power series. And before we get into those, remind yourself about what an infinite series is. And an infinite series is a sum of terms from your first term out to an infinite number of terms, where you develop each term just by plugging in the correct value of n. What a power series is, it's the same infinite series starting from some starting index out to an infinite number of terms, but now those series terms become coefficients on powers of x, and the powers of x are determined by the index in the series. So expanding this out, if I had a series in the form a sub n times x to the nth power, it would be a sub 1 times x to the first plus a sub 2 times x squared, and so on, out to the nth term. And a power series, now that we've incorporated this variable x, a power series is used to model some function of x. So our end goal for what we're looking at with power series is learning how to model functions using an infinite series. And so what we're going to develop is the ability to turn non-polynomial functions essentially into polynomials. So for example, if you look at the series from 1 to infinity for x to the n over n, this would be x over 1 plus x squared over 2 plus x cubed over 3, and so on, out to the nth term. And what we were saying is that there is some other function of x that this infinitely long polynomial can be used to model. But the question that's going to come up is, can this series actually be used to accurately evaluate f of x? It's an infinite series and we can't actually get out to an infinite number of terms. Well, the answer is yes, but only when the series converges. And that's the purpose of all the convergence tests you would have already learned up to this point. It's all been building up to this idea. And so the question we'll look at in the other part of this video is, when does that happen? When does a power series converge and take on the values of another function?